Excellent. Let's go ahead and get started. What I have here is some example problems for the Unit 3 exam that I'd like to go through. So let's just dive into it and get started. This first problem, what we're looking at is out of section 9, or chapter 9. And what we're looking at here is, we'll just go through a couple questions. So let's suppose we want to figure out a confidence interval. Okay, so we want to know how many times on average Phineas asked for candy, and we have a record of the number of times he asks over 30 consecutive days, and instead of having that raw data, we just know that the mean is 8.2 and the standard deviation is 3.1. So if we want to go ahead and compute something, we're going to, on our calculator, press Stat, go over to Tests, and number 8, T-interval, because we're doing a confidence interval with numeric data. Okay, so once we get to T-interval, we have the stats for the sample, not the raw data. And so we enter that in. The mean is 8.2, the standard deviation is 3.1, our sample size is 30, and because we want to do a 96% confidence interval, our C level is 0.96, and we press calculate. And so we get a confidence interval, 6.983 to 9.417. Okay, so this is our confidence interval, and this is how we're going to go about finding it. All right, so now let's see if we can answer some more questions. Interpret this confidence interval. So let's figure out what this means. Remember that when we're looking at a confidence interval, we already know everything about a sample. What we're trying to figure out is about the population. In this case, our sample was on a set number of days. What we're looking at now is for all days. So we can be 96% confident that on any given day, well, let me back that up, that the mean of all given days so the mean number of requests for all days is somewhere between 6.983 and 9.417. Okay. All right. Now, suppose my wife claims that Finney asks for candy a dozen times a day. Let's do a hypothesis test to see if that's true. See if her claim has any validity. So, if we're doing a hypothesis test, we first need a null and alternate hypothesis. In this case, we're hypothesis testing to see if he asks for candy a dozen times a day. So our null hypothesis is that the mean number of times he asks for candy is a dozen, or 12. And our alternate hypothesis is that it's not 12. Okay, and alpha is 0.05. That was given in the problem. Okay, so what we're going to do is go to, on our calculator, use Stat, Tests, And since we have numeric data and we're doing a hypothesis test, we're going to do number 2, the t-test. So let's go to our calculator, stat, tests, do the t-test. And once again, we're inputting the stats. Our null hypothesis is 12. We have our mean and standard deviation of the sample size. Down here, we pick what we entered for the alternate hypothesis. It was at a not equal to, a less than, or a greater than. And we hit calculate, and we get a p-value. Okay, now a p-value is a probability, so it's always a number between 0 and 1. So in this case, we want to be careful of the scientific notation. So here our p-value is 2.9 times 10 to the -7th. Or move the decimal place to the left 7 places. So that is our p-value, and what that represents is the probability that we got a sample this extreme if the null hypothesis was true. Okay, and since that p-value is less than alpha, that's our threshold for what we consider a super rare event. We say because it's less than alpha, we reject the null hypothesis. Okay, we don't think that it's likely that that null hypothesis was true given this sample. So now let's actually come up with a conclusion. Rejecting the null hypothesis is not a conclusion. So here's our conclusion. Okay, so our conclusion is we rejected the null hypothesis. The null hypothesis was that the mean is 12, so we think that it's certainly not 12. Okay. So we have statistical evidence at the alpha equals 0.05 level of significance, that the mean number of requests for candy is not 12. Okay. So our conclusion has to relate back to the problem. It can't just be a reject or do not reject. It has to be something that makes sense. Okay.